Hi everyone, welcome back to my LinkedIn slash YouTube channel. And yes, I'm posting it on YouTube as well from now on. I suppose, I'm planning to at least. I'm studying for the IBM certification on machine learning, and I would like to share my progress here as I advance on my studies. I'll try to summarize everything as easy as possible so everyone can understand, including me, of course. So let's start by understanding what ML is and how it works. Well, ML is within the AI bubble, as well as many things, as we can see in the image here. ML consists of algorithms and it needs us to process raw data into some valuable information. And this process is what I call feature engineering. Well, it teaches computers to learn from data, identify patterns, make decisions, and it does not rely on a fixed algorithm. So it means that it kind of that learns by itself without some explicit instruction by us humans. We just kind of that like guide the way for the computer to learn. There are some approaches to train our machine learning algorithm. The two most common are supervised and unsupervised learning. Uh, the supervised trains on label data and enables predicting unknown labels by making inferences on new data. On the other hand, the unsupervised trains without labels, so the opposite to supervised training, and it finds patterns in data but cannot really predict unknown labels since we don't have any tagged outputs or labels. There's also the semi-supervised, where it iterates through small subsets of labeled data. So basically it's the same as supervised learning, but we just divide our data instead. Last but not least, this one's a little bit different. The reinforcement learning, it learns from feedbacks and it simulates an AI agent to learn. So it gives the feedbacks for the machine learning and it learns from this feedback. So after we choose our approach to algorithms, we need to think in what technique we're going to use for them. There are a couple, and I'll go through them all, but I'll focus only on the first three here, which are the most common for us in the beginning. So let's start it backwards by recommendation system technique. Well, as the name says, it creates a relationship between people who have, for instance, similar tastes and recommends items to them. It's very used in shops or movies and music apps. Dimension reduction reduces the data size. It's used when, for instance, we have like too many more features than observations, or when our model training time is too high, so it's taking too much time to training, so we need to reduce the data size. There is sequence mining. It predicts next events. So for example, in an e-commerce website, when a person click on the cart, they usually click on the checkout right after it. So anomaly detection, as the name says as well, it detects unusual cases like credit frauds or like to find unusual patterns in machines and patient vitals or in products in general. It's used to predict potential incidents overall. Association technique finds items or events that often occur together, like items bought together in a supermarket. Now going to our top three here, clustering. Clustering is used in the unsupervised scenario. So it means that we don't use labeled data here. It groups similar data points together into clusters. It is based on the data points characteristics. And in this way you can use it, for example, like grouping customers based on their behavior. We can identify outliers, numbers really out of range. We can divide images and Much more. Now regression is used to predict continuous values. It finds relationship between the feature, which is our input, and the target, our output. Things like house pricing, forecasting sales, or identifying risk factors are some use cases for the regression technique. The classification predicts class or categories, like whether a cell is good or bad for us, or whether our customers will cancel the service. Well, classification and regression, we've gone through that already. The application of machine learning, I've cited some there. So here, basically the image is showing the cell example. So if we take a close look here, we can see that the human cells has different and unique features. So a data set for a cell, it will look something like this. And we can use these different characteristics to train our model and make it tell if a cell is whether benign or malignant. Some other examples are Netflix and Amazon, with suggesting movies and our products, banks when they approve or deny loans, telecommunication companies. It can be used anywhere really. And there's the image recognition. I've made a video about it on my LinkedIn. You guys can check it out. I've created an image classifier using the classification method. Basically the same here. I just didn't use dogs and cats. I used Charmanders and Pikachus, if I recall. Now let's talk about the machine learning life cycle. Simply put, the steps. The cycle is iterative, so we often come back and forth with the process here. As everything we do in computing, we first need to define a problem we want to solve and have an idea of how we're going to solve it. After that, we collect the data and prepare it by cleaning, removing unnecessary values or incomplete values. We format the data, we label it if it's the case, we can create features and so on. Here is the part where we're gonna spend most of our time really. After this, we can go to developing our model and evaluating it. So first we explore but existing frameworks and see if and which one fits better to the problem we're trying to solve. And then we try different techniques. We evaluate our model over and over again. And here is the experimental part. We're gonna train, test, maybe change the framework, maybe change the techniques to get the best result possible. Minimize our loss and all this stuff. Then we deploy it, and after deploying, we gotta keep track of the model. If new data comes in, or if the model somehow starts to get a high value of loss or something. There are some tools used to assist build our pipelines, aka our workflow. I left some comments here on the side, you guys can see it. It's kind of a dictionary. So yeah, the two most common tools here are Pandas and NumPy. We're gonna use them almost all the time in every project because they allow us with data manipulation, analysis, complex computation with some tricky arrays like the multi-dimensional arrays. Scikit-learn, basically the core library of machine learning. It's open source, has a big community, really useful for ML algorithms in general. Some worth mentioning are TensorFlow, Keras, and PyTorch. They are deep learning tools and they do help a lot when it comes to building our model. Again, Scikit-learn is the core because it does many things, and I'll show you what you can do with a few lines of code using it. In the image you can see some things Scikit-learn has implemented, but getting to the code, like with this single line here, we can standardize our data set. With this line, we can split our data into training and test set. We usually want to split our data to make our model learn and avoid overfitting, which is kind of that memorizing instead of learning. Mainly for unseen data, it can go well on seeing data, but on unseen data, kind of that mess up. So we usually split our data and standardize if our values are too discrepant from each other. And here you can instantiate a model using SVM. It's good for performance on unseen data again, maximize the distance between support vectors. Anyway, we'll see more later. There's an image here explaining a little bit of what SVM does, support vectors, hyperplane, separating different classes and stuff. Anyway, let's say we prepared our data there and we can easily train our model here with fit and predict functions. If you want to, we can add some metrics and save our model in a pico file, for instance. It can be .pico or .pkl as well. It's a type of file specific for Python to store serialized objects. Well, that was a lot, I guess, but it's the basic concepts and some explanation about how and what we're gonna do next on. Hope you guys liked it. Any concerns or suggestions are more than welcome. And see you later.